Greetings, I'm Rajkumar Parachari and I love doing physics. Today I'm here with the instrument Vernier Caliper, and the objective is to help you out in identifying its part, to explain working principle of the Vernier Caliper, and we'll also be doing experiment as suggested in CBSE curriculum. Let us try identifying parts of a Vernier Caliper. You see, this is the main scale and the corresponding vernier scale. If you could see, these is small 10 divisions. These two happens to be the lower jaws and these two happens to be the upper jaws. And this is the metallic strip. Lower jaws are used to hold object from the external side. And hence we should be able to measure the external diameter of a cylindrical or the spherical body. Upper jaws are used to hold the object from inside, and hence we should be able to find internal diameter of the given cylinder. The metallic strip is used to find the depth of a calorimeter of a given cylinder. Right now the length of the metallic strip is less than the depth of the calorimeter. Then what we do is that we place the calorimeter like this and then push the sliding part of the Vernier calipers inside. So there is a moment when this touches. Now as the strip touches the bottom, now we know that the length of this strip will be same as the depth of the given cylinder. So we'll record the reading from here to find the depth. Young friends, what you see on the screen is a Vernier caliper with jaws closed. In this case, 0 of the vernier scale is exactly coinciding with the 0 of the main scale, and if you could see carefully, the 10th division of the Vernier caliper is coinciding exactly with the 9th division of the main scale. The magnified view of the main scale and the vernier scale of this region has been shown within this figure. You could see 0 of the vernier scale is coinciding with the 0 of the main scale, and the 10th division of the vernier scale is coinciding with the 9th division of the main scale. Separation between any two divisions of the main scale has been chosen to be S, and S got to be the least count of the main scale, and this is equals to by default 1 millimeter. Next part, the separation between any two gaps on the Vernier caliper has been chosen to be V, and we need to find what this value V is. It should be clear from the diagram that 10V is equals to 9S. Is it right? Keep counting the gaps. For the more clarity, 1V, 2V, 3V, 4V, 5V, 6V, 7V, 8V, 9V, 10V. So that makes 10V. And at the top you could see 1S, 2S, 3S, 4S, 5S, 6S, 7S, 8S, 9S. So we should be able to write that 10V is equals to 9S, and S happens to be 1 millimeter. So 10V is equals to 9 mm, and this implies that V is equals to 0.9 mm. So the separation between any two consecutive division on the vernier scale is equals to 0.9 mm. If I ask by what amount first division of the main scale is ahead of the first division of the vernier scale, yes, come up, and I guess you should be able to guess this is equals to 1 mm and this is 9 mm. So this gap between the two got to be how much? This gap got to be 0.1 mm. Similarly, if I ask by how much amount second division of the main scale is ahead of the second division of vernier scale, you should be able to make out, because this gap got to be 2 mm, and one division of the vernier scale is equals to 0.9 mm. So right from this position to this position, this distance got to be 1.8 mm. You're right. So this division, I mean this difference between, so the difference between the second division of the main scale and the second division of the vernier scale got to be equals to how much? This got to be equals to 0.2 mm. And similarly, we can proceed and we should be able to make out the separation between third division of the main scale and third division of the vernier scale got to be 0.3 mm and so on. Now see, you have seen in the vernier scale setup, the vernier scale can be moved over the main scale. Is that right? So over here in this particular diagram, I have used two sheets. You should be able to see this with clarity, I guess. Now next, if I happen to move the vernier scale ahead in the forward direction such that the first division of the main scale coincides with the first division of main scale, my question is by how much amount I have moved the vernier scale. Yes, you're right. This got to be 0.1 mm. Is that right? And if you want to see it from here, so this separation, I mean from the left side, should also be 0.1 mm. And if I place the vernier scale over here, so because I have moved ahead, if I have moved ahead this vernier scale, so you see as I move ahead this vernier scale, if you could see this gap between these two jaws also increases. Is that right? So in fact, in this case, when the first division of the vernier scale coincide with the first division of the main scale, then the gap between these two divisions got to be equals to how much? 0.1 mm. 0.1 mm. It means 0.1 mm now has become the least measured distance. Is that right? And this also happens to be the least count of the vernier caliper. Is that right? Now you see, if I happen to move this vernier scale further, ensuring that the second division of the vernier caliper coincide with the second division of the main scale, then definitely I have moved the vernier scale ahead in the forward direction by 0.2 mm. Is that right? And similarly, if I keep moving vernier scale in the forward direction and ensure that that one of the division coincide with the main scale, then we should be able to find out by how much amount the vernier scale has been moved ahead the initial reference point. Is that right? Means if you see over here, third division of the vernier scale is coinciding with the third division of the main scale. So I am sure that this vernier scale has moved ahead by 0.3 mm. Is that right? And the gap between these two jaws got to be equals to 0.3 mm. And for a benefit, I should also be able to tell you this, the strip, the metallic strip has come out, and this has come out only by 0.3 mm. And the gap between this point on the upper jaw and this point on the upper jaw got to be 0.3 mm as well. Let us see how this arrangement helps us in recording the gap between the two lower jaws. Class, you see this vernier caliper carefully. Wanted to measure the separation between these two lower jaws. Is it right? And this separation got to be same as this separation of the upper jaws, and also this got to be the length of this metallic strip. This length, this gap and this gap, they got to be same all the time as the vernier scale is slided over the main scale. Next part, if you wanted to measure, you need to record main scale reading as well as the vernier scale reading, and let's see that how this is recorded. I want to zoom this vernier caliper a bit. Let's see that how really let's see that what I can show you with little more clarity. In this case, in this zoomed picture, in this magnified picture, if you could see, 0 of the vernier scale lies between 2.4 and 2.5 mark of the main scale. So for the more clarity, let I draw this over here. This happens to be 2.4 2.4 centimeter mark, and this happens to be 2.5 centimeter mark, and the zero of the vernier caliper is somewhere close to this. Is it right? This is zero of the vernier caliper. Now next part. Now see, in normal situation, I mean, if we had used the main scale only, the meter scale only, the least separation we could have measured is 1 mm. But over here, you see, what better can be done is zero of the vernier scale lies between 2.4 and 2.5, and we should try to read by how much amount the zero of the vernier caliper is ahead of 2.4 centimeter mark. So basically we wanted to read this much gap. Is that right? This is the extra distance we wanted to measure. Is that right? So let's try over here. Which division of the vernier caliper is coinciding? Just try to find out. It seems that fourth division of the vernier scale is coinciding with one of the division of the main scale, and hence, I mean, what I should be able to conclude is that the zero of the main scale, I'm sorry, zero of the vernier scale is ahead by how much amount? Can you remember the discussion I did over here in this case? You see, because the fourth division, let me move this little ahead, third, fourth. If fourth division of the vernier scale, coincide with any of the division, then I should be sure that this vernier scale has moved ahead by how much amount? This should be 0.4 mm. Is that right? The vernier scale reading should be, vernier scale reading is equals to 0.04 centimeter. How? Because the fourth division is coinciding and the least count happens to be 0.1 mm, and which happens to be how much? 0.4 mm or 0.04 centimeter. Now the total reading in this case got to be, just add these two and you should get equals to how much? 2.44 centimeter. You see, so let's try to record one more reading for the benefit. Class, in this situation, if you see that the zero of the vernier scale lies between 3.0 and 3.1, and hence the main scale reading got to be equals to how much? This is 3.0 centimeter. Now we need to record the vernier scale reading, and for your benefit, whatever I could see carefully within this, I should be drawing for you. This happens to be 3.0 mark, and this is 3.1 centimeter mark, and zero of the vernier scale, that is close to this point. Is it right? Little ahead of the middle. Is it okay? Now you see over here, if I try to see, it seems that the sixth division, you need to see this carefully, that sixth division of the vernier caliper is exactly coinciding with one of the division of the main scale, and in this case, because it's a sixth division that coincides, and hence the vernier scale reading that got to be equals to how much? 0.06 centimeter, and the reason you already know. So this is equals to the total reading in this case. Total reading in this case equals to how much? 3.06 centimeter. So I've given you two examples. Now I should switch over to the actual experiment. Class, you're given a calorimeter. So calorimeter happens to be a cylindrical object, and we are supposed to find its external diameter, its internal diameter, as well as its depth. And let's see that how this could be done with the help of a vernier caliper. So let's proceed. Class, you see this vernier scale can be slided. Is that right? As the vernier scale is slided, what happens? I mean, the separation between the jaws, between the lower jaws as well as the upper jaws changes. And you see the length of the strip also changes. What I'm doing is that I will be holding this cylinder with the help of vernier caliper, and definitely I will be using the lower jaws, and will try to record reading, and let's see that how Could you see the main scale reading? The main scale reading, you see zero of the vernier scale that lies between 2.6 and 2.7. So main scale reading in this case will be 2.6 centimeter. Is that right? And wanted to see by how much amount zero of the vernier scale is ahead of 2.6 centimeter mark. I guess you understand what I'm saying. And if I could see that which division coinciding, just try. For me, I mean, it is either the 8th division or the 9th, 8th, 8th division that coincide best. Is that right? So I will take 8th division of the vernier scale is coinciding with one of the scale of with one of the division of the meter scale, main scale, and hence I should be able to write the whole reading. So in this particular case, main scale reading happens to be 2.6 centimeter and the vernier scale reading should be 0.08 centimeter. Is that right? So let us record it. So over here, this is the table, the external diameter. This is what we wanted to do. The first reading, the main scale reading got to be 2.6 centimeter. The vernier scale reading, because it's the 8th division coinciding, least count is 0.01 centimeter. And this is equals to 0.0 0.08 centimeters. So the total reading got to be equals to 2.68 centimeters. So this is the first. So this is the first reading. Is that right? Now next. Now repeat this experiment, but hold this calorimeter at a different point. Is that right? And let's see that what do I get as. So over here, zero of the vernier scale is close to 2.7 mark. Is that right? 2.5, 2.6, 2.7 mark. And it is the 9th division that is coinciding. Is that right? So let's write this is 2.6 centimeter. It is the 9th division that is coinciding, 0.01 centimeter. This is 0.09 centimeter. So this is equals to 2.69 centimeter. Now let's record the third reading. Now hold this cylinder within these lower jaws and see that what is the reading like. And what I see that zero of the vernier scale that lies between 2.6 and 2.7 and which division coincides? Could you see carefully? I could see still it is, you can say it is, sir, 8th division, 9th division. So whichever, I mean, you want, you can, I mean, this is purely your choice. It seems to me it is 8th division that's coinciding best. So 2.6 centimeter. This is 8 multiplied by 0.01 centimeter, and this is equals to 0.08 centimeter. The total reading becomes 2.68 centimeter. Is that right? Similarly, can proceed with the 4th reading and the 5th reading. Anyway, let's try it fast for you. So for me, this is 2.6 centimeter, 2.6 centimeter, and it is the, again, is the 8th division that is coinciding, 0.1 centimeter, and this is 0.08 centimeter. This is 2.68 centimeter. And let I hold it at another point close to the top, and it is again what I see this as 2.6 centimeter happens to be the main scale reading, and it is the 9th division which is coinciding, 0.01 centimeter. It is 0.09 centimeter. This is equals to 2.68 centimeter. Now we'll take out the average. So this is equals to 2.68 plus 2.69 plus 2.68 plus 2.68 plus 2.69 divided by 5. This is equals to 2.684 centimeter. This 4 we need to omit because the accuracy of the instrument is up to 2 decimal places, and hence This final reading is 2.68 centimeter. So again, I want to share this very important point with you, that when the gap between the jaws is 0 and 0 of the Vernier scale coincide with the 0 of the main scale, it means that there is no initial error, there is no zero error, and hence the external diameter still remains the same. Zero error of the instrument is equals to 0.00 centimeter. So still the final reading is 2.68 centimeters. Now class, now the internal diameter. How the internal diameter should be done, this is what now I wanted to share with you. Here is the calorimeter, and this is the Vernier caliper. Is it right? Now what do you do? Now you turn it, put these jaws inside, put these two jaws inside the calorimeter and move out this Vernier scale. In the process, what happens, that the upper jaws, they holds this cylinder. Is that right? So whatever is the internal diameter, we should be able to record just by looking at this. So what I see, that 0 of the Vernier scale is exactly at 2.6 mark. Is that right? In fact, 0 of the Vernier scale is coinciding exactly with 2.6 centimeter mark. Is that right? So I mean, this is a special case. Over here, the main scale reading happens to be 2.6 centimeter, and it is a 0th division that coincides with one of the division of the main scale. Is that right? So the reading of the Vernier scale is 0.00 centimeter, and the total reading becomes 2.60 centimeter. Now next take another reading of the internal diameter. So again, repeat the thing. Lower the upper jaws inside the calorimeter and pull out the Vernier scale. Now this cylinder has been held by the upper jaws. Now let's see that what it is. It seems 0 of the Vernier scale lies between 2.5 and 2.6 centimeter mark. And which division it is coinciding? Just try to see. It seems to me it is the 7th division that is coinciding. Is that right? It is the 7th division of the Vernier scale that is coinciding with one of the division of the main scale, because 0 of the Vernier scale lies between 2.5 and 2.6, and hence the Vernier scale, the main scale reading is 2.5. We always choose the lower, and the 7th division is coinciding. So this is 7 multiplied by 0.01 centimeter. So this is equals to 0.07 centimeter. The total reading becomes 2.5 centimeter. Now again repeat. This is the calorimeter. Lower these upper jaws and move out the Vernier scale, and let's see that what is reading like. In this case, if you could see that the 0 of the Vernier scale lies between 2.5 and 2.6, and hence main scale reading got to be 2.5 centimeter. And which division is coinciding? Can you tell me which division is coinciding? It seems in the 4th division. Yes, it is the 4th division that is coinciding the best. So this is 4 multiplied by 0.01 centimeter, and this is equals to how much? 0.04 centimeter. This is 2.54 centimeter. So I have taken all other different readings. We'll take out the average. The average internal diameter. Internal diameter. This got to be 2.60 plus 2.57 plus 2.54 plus 2.56 plus 2.56 divided by 5. This is equals to 2.566 centimeter by calculation. We need to round off this 6. So the final answer is 2.57 centimeter. Zero error of the instrument happens to be 0, and hence the corrected value is still got to be 2.57 centimeter. Now the internal depth of a calorimeter or a hollow cylinder. So here is the hollow cylinder I have been using, and we are supposed to find out its internal depth. We already know how to do that. We will place the vernier caliper like this, and we'll slide down the vernier scale downwards. We'll do this till the bottom of this metallic strip touches the base of the cylinder. Once this has been done, we'll record the length of this strip, and the length of this strip can be recorded by reading both the meter scale reading and the vernier scale reading. So to do it, I would like to magnify, and let's see that what do we see. Here 0 of the vernier scale lies between 5.3 and 5.4, and hence the main scale reading is 5.3 centimeter. Now let us check which division of the vernier scale coincide with any of the division of the main scale. It seems that the 9th division of the vernier scale coincide with one of the division of the main scale, and hence the vernier scale reading got to be 0.9 mm. Now let's write this value in the table. Here main scale reading is 5.3 centimeter, as the 9th division coincides with one of the division of the main scale, and hence the vernier scale reading got to be 0.09 centimeter. The total reading becomes 5.39 centimeter. We will record 4 more reading of the internal depth of the calorimeter. Because you already know how to read the vernier caliper, so I will be filling up this table for you. So class, these are the 4 other different readings for the internal depth of the calorimeter. Now the average value of internal depth will be average internal depth. This is equals to 5.39 plus 5.38 plus 5.39 plus 5.39 plus 5.39 divided by 5, and this is what you get as 5.388 centimeter. I need to round off this 8 because of the obvious reason, and equals to 5.39 centimeter. So this got to be the average total internal depth of the calorimeter. Now let us see what other physical quantities we have already measured. We have already measured internal diameter of the cylinder, that got to be equals to 2.68 centimeter, and we have also measured the internal diameter of the cylinder, and that was 2.57 centimeter. So using these readings, what actually we can do, we can calculate the internal volume of this cylinder. The internal volume of the cylinder should be given by pi internal diameter is square by 4 into Hn. And this Hn is same as the depth, internal depth of the calorimeter. Now substitute these values. This is equals to 22 by 7 multiplied by the internal diameter was 2.57, and hence this is 2.57 multiplied by 2.57 divided by 4, and this is 5.39, and this is equals to 27.9 centimeter cube, keeping significant figures in mind. So what else can be done knowing these values? Class, if we try to find out external height using the Vernier caliper, then we will be able to calculate the metallic volume of this cylinder. Let's see that how can we do that. So class, we already know external diameter. External diameter. This is equals to d external equals to 2.68 centimeter, and assume that we also know h out, the external height of the cylinder, and by using the formula pi d external square by 4 into h out, we should be able to calculate the external volume of the calorimeter. And by subtracting internal volume from the external volume, we should be able to find out the volume of the material used in constructing this calorimeter. Is that right? And let's see that. Class, what else I have for you? I have a solid cylinder in front of you. This is in fact a cell, AAA cell. We should be able to find its diameter. We should also be able to find its height. By knowing its diameter and height, we should be able to calculate its volume, the volume of this cylinder. Is it right? And I also have a cuboid in front of you. By knowing its breadth, by knowing its length and height, we should be able to find out its volume as well. And thank you so very much for listening me patiently this long. God bless you.